Welcome back, Contemporary Math. We are in chapter 3D. So we're going to start talking about index numbers in this chapter. We're going to talk about this. It says index numbers of CPI and beyond. So we'll talk about the CPI and what that means in a minute. The first thing that we're going to talk about is what is an index number. So here's a definition of the index number. So an index number provides a simple way to compare measurements made at different times or in different places. The value at one particular time or place is chosen as a reference, and the index number for any other time or place is, and then they give us this formula: index number equals the value over the reference times 100. So you might notice we're doing this times 100 thing. This index number looks a lot like a percent. So even if you look down at this table, you might notice the price index, or this is the index number, is basically it's a percentage without the percent sign. So we drop the percent sign and we call it an index number. But what we're comparing is two different values. So this is like when we compared and said the word of. So we want to know what percentage of this thing is of this, right? And so probably some solid numbers instead of just saying of all the time might be a bit better. But this is the price, so this is sort of how the table's arranged. You got your year over here. This is the price, and I believe this is the price of just like one item. I believe it's a gallon of gas is what they're doing. And so we're comparing the price of a gallon of gas across the decades there. And so I think if we jump into this first one, we can get at where these numbers are coming from. But if we just do the value over the reference, so if this is price as a percentage of 1970 price, hopefully you notice this is going to give us 100%. So if we start at 36 and divide by 36, multiply it by 100, 1970 price is 100% of a 1970 price. It is itself is what this is saying. So you might notice things that are below, like 31%, are going to give us a lower percentage. Things that are above are going to give us a higher percentage. So this is sort of like our base is what we're doing. Suppose the cost of gas today is $2.20 per gallon. Use the 1970 price as a reference value. Find the price index for gas today. So this is 2 years old probably when I wrote this, but in 2018 price is what it should say. Probably 2018 might be better to say on there. Huh? Okay, so suppose gas and cost of gas in 2018 is $2.20. What is that if we use 1970 as a reference? So we're taking $2.20. That is the value we want to talk about. The reference value is the 0.36, or the price in 1970. And we got to multiply this thing by 100. So if we do 2.2 over 0.36, should be giving us something like 6.1 repeating, so 6.11. I'll go ahead and do 3 decimals. And so I should be getting something like 611.1. And so if you want to fill out the table, you could absolutely fill out your table with 1.1%. Okay. So we're doing the same thing with all these other numbers. If you want to check all these other numbers, it should be the same thing. 2.84 divided by 0.36 should be giving me, what, 7.899. Then I have to multiply by 100. So 788.9. So we're just taking each of these numbers and dividing it by 0.36. Multiply it by 100 should be giving you this or this number. Same thing. Just the price index, just remember, like, it doesn't have the percent. So we drop the percent to get to the price index. But it's basically a percentage, right? Okay. So now this one says making comparisons with index numbers. So we talked and defined what an index number was. And so they say use that table to answer the following. Suppose it cost $7.50 to fill up your tank in 1970. How much did it cost to buy the same amount in 2010? So this is sort of like we want to, there's a sort of rate that this thing gets inflated. And so we're using this index number to kind of capture this rate. And so essentially what we want to do is we want to write sort of similar ratios between these prices. And so we want to think about like two sorts of things: price in 1970 is one thing that we're thinking about. And then the other thing that we're kind of thinking about is the price in 2010. Yeah, that's nice stuff. We want to write sort of equivalent ratios about these things. So if it cost me $7.50 in 1970 to fill up, we want to know how much it will cost in 2010. So this is the thing we want to know. If you want, you can put a question mark, you can put an X, but this is the sort of ratio I'm thinking about. So I want to capture this with a sort of like price index. So if I think about my price index, I go back to my table. And I'm looking at 2010 and 1970. So the 1970 price, hopefully we got that already, is the 0.36. The 2010 price is $2.84. And so this is sort of like when we're writing those similar triangles, we have a similar ratio that one sort of follows and the other follows. The rates should be similar, right? It is inflating at the same sort of rate. And so if it's going from 36 cents to 2.84, this should be going from 7.50 to, this is the thing we want to know. So this, we have had this sort of set up before, but the quickest sort of way to do this without explaining a whole lot is to just go and do that cross multiplication. So 0.36x equals 7.5 times what, 2.84 is what I'm trying to figure out. Let me get that on there. $7.5 times 2.84 is giving me 21.3. And so I want to solve for x. I'm dividing by 0.36. So for my x, I'm getting 59.1666 repeating. So I want to know probably to the nearest, no, 59.17 would be what it rounds to. Sorry. Round it up. So quick recap of what we just answered. Suppose it cost you $7.50 to fill up a tank in 1970. How much is it going to cost in 2010? So if it costs you $7.50 in 1970, it's going to cost you $59.17 in 2010. So this is a thing known as inflation. So prices tend to inflate over time. Suppose it cost $16 to fill up your tank in 1990. How much did it cost to buy the same amount in 1960? So I want you to try this one. I want you to go back, look at that table. Figure out what's important in that table. Figure out where you're going here. But I believe those are the two important amounts we should be taking out of this problem, right? 1960 to 1970 is what I'm sort of doing. 1960 to 1990. Sorry, the wrong date. And I put them this way. If you reverse your dates, as long as you write this ratio the same sort of way, comparing 1960 to 1990 and 1960 to 1990, you should be all right. There is another sort of way to do this as well, right? We could compare this one to this one and this one to this one. And when we do our cross multiplication, it would be the same way. So we had the same, there's a similar sort of issue that occurred and arose when we did similar triangles. You could set it up at least 2 different ways. Same thing here. You can set this up at least 2 different ways. So if you're doing it another way and it makes sense to you and it's coming out exactly the same way it's coming out for me, then good. If you're not getting the same thing, then you might want to like reobserve how you're doing things, right? But if we're going from 1960 price is 031, and then we're going to go from 031 to 123 for 1990. So this is my first ratio that I'm setting up. So this is the ratio coming from a price of gas. So this price of gas should increase at the same rate or decrease at the same rate as this thing. So this is a price of gas, $16, and this is in a 1990 price. So now I want to figure out what it is in the 1960 price. That's what the question asks. So this could be my variable. So I'm doing 1.23x equals 0.31 times 16. 1.23x is equal to 4.96. And so I'm dividing by 1.23 to solve for x. So my x is getting something like 4.032, 4.0325, something like that. So I want to round to probably do 2 decimal places to tell them a price of gas is going to be 403 for the tank of gas. And hopefully this makes a little bit of sense in the context of the problem. So if we went from a price that was in 1990, it should be going hopefully down if we're going to 1960, right? And vice versa. When we went from 1970 to 2010, the price should have went up. So thinking about like looking at the big picture and sort of making sure your answer makes sense in the context of the problem, it might help you out, right? Okay, so using the 2010 price as the reference, find the price index of today's gasoline is $2.20 per gallon. And compare that to the previous solution from example 1 where 1970 was the reference. Okay. So now and they tell us kind of what to put on bottom. Our reference value should be from a table. So we're going back, we're looking at that table once again. They want the 2010 price. The 2010 price is $2.84. We're comparing that. The value that we want to compare is the $2.20 per gallon. 100, convert it from a decimal to a something that looks like a percent, but that doesn't have a percent sign, basically. 2.2 divided by 2.84 is going to give me 0.7746. And I got to move it 2 decimal places to make it 77.46. So the price index is 77.46. And now they asked me, we're looking at the 2018 price. How does that compare to the what? The 611.1? That is smaller. So why is it smaller? The 1970 price was 0.36. So our denominator got larger. Our overall number or our index will get smaller, basically. Number on bottom get big, number on top gets small. Okay, consumer price index. So far we have been basing everything, the whole inflation sort of thing, off of the single price of a gallon of gas. So you might realize basing inflation in the way that goods inflate and everything around us off the price of a gallon of gas may not be the best sort of metric to grab at that. So there's this thing called the consumer price index. Oh, and look, now they're finally defining inflation. So inflation is the rising of prices and wages over time. So that's what's been happening. That's what we've been figuring out. We've been figuring out sort of like what happens, what the value is due to inflation. That's what I'm trying to say. And so inflation is the rising of prices and wages over time. So they don't just take a gallon of gas, they take this thing called the consumer price index, and they average a bunch of goods and services and housing costs. And it's computed and reported monthly. I want to say it's the on second thought, this consumer price index is chosen by the Bureau of Labor Statistics, or BLS. I know the editors of the Wall Street Journal picked something, and it's in the book somewhere, but I can't find it for the life of me. But it's not the CPI. The CPI is the Bureau of Labor Statistics, which is a government entity, obviously, not the Wall Street Journal. So it is computed. It is computed and reported monthly. Here we have the year, and here we have the CPI calculated. So full disclaimer, these may not be the same thing that are in your book. It might be slightly different, but we can still work with this. So suppose you need 30,000 to maintain a particular standard of living in 1990. How much would you need to have? How much would you have needed in 2012 to maintain the same standard of living? Assume that the average price of your typical purchase has risen at the same rate as the CPI. So again, we want to compare two sort of years. We want to compare 1990 to 2012. And we want a ratio. So in 1990, my CPI is 130.7. So we went from 130.7 to 2012, which is 229.6. And so this is the rate that it should inflate. It should inflate at this sort of ratio. So now we want to figure out, if it was 30,000 in 1990, how much is that going to be in 2012? So now we want to write this. The 30,000 is a 1990 price. The 2012, that's the thing we want to know. That's the thing we don't know. Same thing here is, if you set this thing up as sort of similar triangles from year to year, you should be able to get this, hopefully. So this is 130.7x, and this would be equal to 30,000 times 229.6. And they do give us another sort of formula. So there is probably a shortcut you can use with some of these. But if you know how to do similar triangles or the similar ratios, you should know how to do this sort of thing. It should work out either way. You might just have to do like one extra little step. So this is 6888. 200. 130.7. So definitely using a calculator at this point to figure out these large numbers. So 30,000 times 229.6 is going to give me that number. Now I'm dividing by 130.7. So I'm getting something like 52,700.84. Okay. And so stepping back and trying to talk about what this sort of thing means and seeing if it makes sense. So 52,700, 84 cents probably doesn't matter. If you just tell me 52,700, that's probably pretty good. If you're making 50K, I don't think you're going to care about 84 cents too much. So does it make sense if you made what? 30,000? Let me bring this down a little bit. If you made 30,000 in 1990, does it make sense that you might need 52K to make it in 2012? So due to inflation, that seems probably about right. So again, when we talk about amounts and how much cheaper certain things were, we do have to account for like the rate of inflation, right? And we can account for inflation over time, and not sure if we're gonna have a. Yeah, I don't think we'll have another one. But we could technically do the rate from one city to another, right? Different cities have different rates or indices of living, as they say. So things cost different prices, different places. Okay, so the rate of inflation from one year to the next is the relative change in the CPI. So if we want to know the rate of inflation from 2006 to 2009, and then they want us to compare it from 76 to 79, but we're going from 2006 to 2009 first. So we want to find the relative change from 2006 to 2009 in the CPI. So this is a list of CPIs. So 2006, I believe, is right here. 2009 is right here. So I'm going from 201.6 to 214.5. So we've talked about relative change, but if I want to do relative change, again, that's that 214.5, and I'm going to subtract 201.6. And if that would be my difference, that would be my absolute difference or my absolute change. But if I want the relative change, I have to divide this thing, and I have to divide this thing by 201.6. And then I have to convert my decimal to a percentage is the other thing. But this is the main sort of setup here. We're doing 214.5 minus 201.6 should give me 12.9. So I'm trying to figure out what 12.9 over 201.6 is going to be. And it should be giving me something like 0.0639. And I still got to convert that. So this should be giving me, and I guess you have to convert things correctly, should be 2 decimal places. So this should be 6% or 6.39%. So the rate of inflation from 2006 to 2009 was 6.39%. And now the other thing they want us to calculate is from 76 to 79. So we do that by looking up at the table. 76 is here, 56.9. 79 is here, 72.6. So hopefully subtracting 56.9 from the 72.6. This would give me the difference. This would give me the rise. If I want the relative difference, I have to divide this by 56.9, have to convert it to a percentage. If I take 72.6 and subtract 56.9, I should get 15.7. 15.7 over 56.9, convert to a percent. I should be getting something like 0.2759. I still have to convert. So this is what, 27.59%. So again, you might want to, like, one thing you might want to do is keep a sort of eye on the units that we're using. When we do relative change, when we do rate of inflation, that is the relative change. That is a percentage. The CPI, we don't put a percent on, but it is a percent. So track of like the sort of format these things are in, but we are talking about 27.59 versus like 6.39. I don't have them both on here. There we go. These were the two numbers we were talking about. This was from the 2006 to 2009. This was from the 76 to the 79. So what do we notice? Probably the rate of inflation from like what, 76 to 79 is going to be a lot larger. And if you look at their absolute change, this is like what, 12.9, 15.7. But this one we're dividing by like 200. This one we're going to divide by 50. So this one would be a lot larger. Okay. And so the final sort of thing, but I don't want to even look at that. So let's compare price, or let's look what we did previously. So we took the CPI, comparing CPI. And let's do, we did 1990 and 2012 previously. So when we did that, we compared the CPI of 1990, we compared it to 2012, and we wrote a sort of equivalent sort of ratio about these things. And we said this ratio has to be equal to a price in 1990. And the thing we found was the price in 2012. So these same things, when I write out ratios of one price in one time to the ratio of another price in another time, if I'm talking about the same sort of objects, they should be similar ratios. They are inflating at the same rate. It should be similar. So this was the format that we had previously. And this was the 130.7. This was the 229.6 that I had previously. This was the 30,000, and this was the 52,700. So this was a sort of form that example 4 was in. If we go back and look at example 4, this was a sort of form we had. Now, if I want to solve for price, and I want to solve for the price in 1990, one way I can do that is by multiplying both sides by the price in 2012. So if I'm solving for the price in 1990, one way I can do that is by essentially multiplying by this. We get rid of it over here, and we would have to place it over here. CPI of 1990 versus the CPI of 2012. And so now we have a formula to find the price of 1 year in terms of a price of another year, where they say Y and X. So if we make 1990 our Y, price in Y, this is going to be the price in X, in year X, over the CPI of year Y, over the CPI of year X. And so this is the formula that they give you on the next page. So if you can write equivalent ratios, and you can write this ratio, right? Maybe convert this to Y's and X's, Y's and X's. That's all they're doing. They're generalizing this into a sort of formula. So if you want, you can continue writing equivalent ratios. That is something you can do. You can absolutely set all these problems up like that if you want. That's all they're doing here. They're just trying to give you a little shortcut to find the price and why. But if you write equivalent ratios, it should be like one step, and then you should be probably where we're going to be, or pretty close. You should still be getting the same solution. 1991, the median household income in the U.S. was $51,791. In 2012, the median household income in the U.S. was $53,331. Compare the two incomes in 2012 dollars. How does this compare to the rate of inflation? Okay, so they're asking for quite a few. They're asking for quite a few things in this problem. So let's focus on the first thing. We want the price in 2012 dollars. Following our formula there might be the quickest way, but we want the price in 2012. In 1998, and we're going to CPI according to like what a formula is up here. So if this is the price in Y, this is the price in X. Then our Y up here has to be 2012, and our CPI down here has to be 1990. 1991, sorry. 1991 was the year I picked. Okay, so the price in 1991 was $51,791. And if we take 51,791 and we multiply it by the CPI in 2012, which is 229.6, which is divided by the CPI in 1991, which is 136.2. I have to divide these two things first. 229.6 divided by like what, 136.2. It's gonna be like 1.658, and I'm gonna multiply that by 51,791. That's it. Should be giving me something like 87307. And if I went around it to two decimal places, it would be 0.00. It would round down to there. Okay, so we're looking at this thing. Compare the two incomes in 2012 dollars. So the median income now is what, 53,331. So that is definitely less than what the median income was in 1991 if we account for inflation. So even though it went up, it didn't go up as much as inflation was going up, right? And so it's going to be less. So if we look at inflation, so doing the inflation is we do the relative difference of the CPI. So we're going to do CPI of what, 2012. So write it out right quick, maybe. 2012, we're going to subtract that from the CPI of 1991, and we're going to divide that from the CPI that we started with, which would be the CPI of 1991. So that would be how we compute the relative difference of those two things, or the general sort of formula. If I want to throw in the numbers, this is 229. The previous problem we just used, they are in the table, is where they are coming from. And we're dividing this by 136.2. So this is giving 0.6858, somewhere around there. When I calculate this, which is giving me 68.58%. So we've done a few relative difference. I'm going probably a little fast over this, but subtract those numbers, divide them. Should give you this, multiply by 100%. Should give you that percentage. The inflation is 68.58%. And so that's the rate of inflation. So I didn't do it, but maybe something to check, or something that might be good to check on this thing, is to see like what these sort of differences between the other two things. So I'm going to do that right quick. I'm going to write out what I'm talking about just so you can kind of see. So if I want to know what the increase from what 53,331 is minus 51,791, so if I want to know what the relative increase of these two guys would be, so that would be the relative increase of the actual household income, or median household income. So 53,331. I'm just going to subtract that from 51,791, and I'm going to divide that by 51,791. And this is giving me about 2.97%. So that might be a good sort of thing to compare it to. So this only went up around 3%. This went up about 68%, was a CPI. So definitely the income did not follow the CPI or the rate of inflation. Okay, and we have one sort of last problem to go over. Did my research on this one. I think this one's pretty accurate. The NES was released in 1985 for $199. The Super Nintendo Entertainment System was released in 1991 for $19.99. If both gaming consoles had risen with inflation, how much would each cost in 2012 dollars? Okay. So the NES, and this is the US release, obviously. It's not the Famicom. So the price in 2012 dollars is what we want to know. And we don't want to know this. We want to start off with the price in the other year, which would be 1985 is the other thing. And now we want to write our CPIs correctly. So CPI, if we look back at the formula, this should be our 2012 CPI. This should be our 1985 CPI. So if we want to know the price in 2012, it was $199 in 1985. Our CPI of 2012, I think we've used that a few times already. That's the 229.6. And the CPI in 1985. So now I'm going back. I'm looking at that table. I'm looking at the year 1985. And if you're looking at the right spot, you should be getting, hopefully you're looking at the table, 7.6. Okay. And like maybe a little bit of visual looking at this thing, looking at the big sort of picture. If the big number's over the little number, this thing should be getting larger, right? So this is another sort of way that maybe you could recognize you're setting things up correctly. Like if we want this thing to get larger, it's obviously going to get larger from 1985 to 2012. We should set it up so that the larger CPI is probably on top, right? The other way around would give us a smaller number. But we're crunching these numbers. So 229.6, definitely going to grab a calculator for this, divide by 107.6. This is going to give me like 2.133 or something. So that's just rounding. So I usually don't round until the very end. I let my calculator do all the dirty work. So you're a few decimal places off. As long as you're showing your steps, doing everything correctly, I don't care about a few cents, especially when we're talking about a couple $100, right? But this should be giving me something like 424, which I think is probably not too far off from how much the new Xboxes and PSs cost, right? I think they just released some kind of updated, upgraded system that's not quite a new system. They keep doing that. It's like, here's the old system revamped. Okay. Here we go. Price The Super Nintendo. So the Super Nintendo got released in 1991. So we're doing price in 1991. And we got to do CPI of 2012 over 91. And running out of room on the paper, but there we go. It's crammed all in there. So the price in 1991, the price that they gave us was $199. And so before we even do this, do you think this one is going to be more or less in price in 2012 dollars? Okay, so let's do it. 229.6, I believe, is still my CPI of 2012. That didn't change. This one is different now, 136.2. So our denominator got larger. So overall, this number should get a little bit smaller, and it does. 335.47 is the number that we should end up getting. Super Nintendo would be worth what? $335.47 nowadays. Okay. So there are a few other index numbers, and there's a brief sort of mention of them. And even with the CPI, there are a few different CPIs that they do figure out. So there's a CPI-W, which does wages, and there's CPI for goods, I believe. There's a producer price index, which tells you the manufacturer's price. There's a consumer's confidence index, which somehow measures the consumer attitudes to save or spend. There are a few other different metrics that they mention really briefly in the book. So there's a short note here, but that's the last sort of problem we're solving in 3D. Stick around. See you in class soon. Thank you for watching the video.